Hello and welcome, my name is Thomas and this is the final episode of my KringleCon 2 write-up screen recordings. We're going to be looking at the final challenge, which is challenge number 12, filtering out poisoned sources of weather data. Now before we do that, we just opened the Slay workshop doors, so let's head on in and see what's happening in there. We already know that it's the Tooth Fairy that seems to be behind all the plotting and all what's happening at Elfview this year. So let's quickly talk to her as to why all of this is happening. So she hates how Santa's so beloved, okay, and she wants to have Christmas cheer and some help as well for all the work that she's doing. And she gets no respect, etc. Okay, so that's no fun. But that's no reason to do all of this either. Before we go into helping Wunorse Openslae, let's talk to Krampus. Okay, there's still time, still the final challenge. We'll do that in just a bit. First, let's talk to Wunorse Openslae. It actually took me quite a while to figure out that name. Openslae was pretty straightforward, but Wunorse, I finally got what it meant at the end of the challenge, basically. Anyway. So I'm pretty sure one of these connections is a malicious C2 channel. We're gonna have to look in that terminal to help him out. Okay, cool. So Zeek JSON analysis. So let's see. Do we have something in there? We have a connection log. Okay. So let's see what's in the connection log. Okay. So looks like JSON. So it looks like braces there, so let's try and see if we can use JQ on that. We're going to cat the connection log, send it through JQ, and then get the first element out of that. There we go. So this is one of the log entries in that connection log file, and one of the things that we notice is that the parameter or the field that we're interested in is going to be the duration, because that's what we need to look for, long durations. So I'm going to do the same thing, but now I'm going to be sorting by duration in reverse order, and I'm going to get that one element. So if we do that, we have to wait for that to finish. We'll get an entry which has this extremely long duration, and that's what we're looking for. And the final solution is going to be what the IP address is for that. So now we need to say run to answer, if I'm not mistaken. Run to answer, I think that was what they said at the top here. Run to answer to submit your answer. And it says submit, at least we'll need to wait. Okay, what is your destination IP address for the longest connection duration? So destination IP is going to be this one. So copy that in, enter, and that is correct. Okay, perfect. Now that you know the features of JQ, you'll be able to answer other challenges too, which is going to be challenge number 12. Okay, let's see. Santa's flight route is planned by a complex set of machine learning algorithms without use available weather data. But all the weather stations are reporting severe weather to Santa's sleigh. So I think someone might be forging intentional bad data. So flummoxed and can't even remember how to log in. Maybe the Zeek HTTP log could help. And then he worries about certain bad activity being local file inclusion, cross-site scripting, SQL injection, and I think something else. Yeah, some shell shock as well. He's shocked about some shell stuff. So that's a good reference to shell shock. I bet you if you pick through, you can find some naughty data from naughty hosts. And if you find a log entry that definitely looks bad, try pivoting off that and finding additional attributes or unusual attributes that can help to find other IP addresses which wouldn't show up as necessarily bad in the logs, but they're bad due to their relationship on that particular parameter. Okay, so let's see. JQ is the tool that we need. Okay. Perfect. So let's look at our badge, the objective, filter out poison data. We have the Zeek logs. Okay. We need to block 100 IP addresses, 100 offending sources, and that is going to be something that we can do at this particular website, srf.elfview.org. Okay, so now we don't have any information about logging in. So that's not something we can use. Okay, so how would we go about doing that? Let's see. One of the things that we had access to a while back was we had information about the Slay route Superslayomatic manual. And the Superslayomatic manual has some interesting details about how everything needs to be set up. And one of those things is going to be information about the Slay Route Finder web API. And one of the things they mention in there is that the default login credentials should be changed on startup and can be found in the README and the LView Research Labs Git repository. Now we have absolutely no information about that, where that Git repository lives, but we do know what a README file in a Git repository typically looks like. That's going to be README in all caps. It's going to be a markdown file .md. So one of the first things that we'll be able to do, let's clear the screen real quick. There we go. So I've downloaded the Zeek logs here. I've already unpacked them. And one of the first things that I'm going to do is I'm going to start looking through those logs to find any URIs or URLs which have README in them, to see if there's anything along those lines. So let's do that now. So I'm going to push that into JQ. I'm going to select everything where the URI matches README. And that's a regular expression basically. So anything where README is inside of the URI, it's going to match. And then we also need to make sure that its status code's 200. Okay, close that as well. Let's see if that gives us a result. Well, it does. And the URI is going to be /readme.md. So let's grab that. Let's head over back to our browser. And let's add that to the end of our server, our web address. And that gives us the actual location of that file, the contents of that file. And then we have the default credentials, which is going to be admin and then this password. So if I go back and now I can log in, I can use those credentials, admin and the password, and we can sign in. So we have some information, API documentation, the weather map, which seems to be bad weather all over the place, even in places where you would expect to see at least a little bit of sunshine. So that's definitely not the way it's supposed to be. And we have a firewall where we can block IP addresses. If we just add one single IP in there, let's actually see if we can add an IP address. Let's see, let's do what they suggest in here, right? So let's say this particular block, say deny. What will happen is it's going to recalculate the route and it's going up. There we go. Bad weather still. Santa would definitely hit one of those clouds and that would be bad. So let's remove that again. So that's definitely not where we need to be. We need to identify a lot more bad activity before we can actually start blocking things. Now, a couple of things that were mentioned by our ELF friend was local file inclusion, cross-site scripting, SQL injection, and shell shock. Let's start by looking for local file inclusion. And local file inclusion can be searched for in the following way. So using JQ again, I'm going to select any URI that contains ... So any means of using a relative path inside a parameter in the URL to try and get access to particular files that fall outside of what would be the normal web route, I guess. And I'm going to look for the IP address, then a tab, then the URI, and then a new line. And that's hopefully going to format that information a bit better. So let me actually enlarge this just a little bit. There we go. So now we have some activity that we found that matches what we're looking for. This definitely doesn't look good. They're trying to use the station ID parameter to actually include the contents of /etc passwd. The same thing happens here, same thing happens here, same thing happens there. That file seems to be something that's really something the attacker is going after. So let's try to look for that instead and see if that gives us anything else. So let's pivot over to that particular value. Again, I'm going to do the same thing here. Look for anything where passwd is in URI, and then we're going to print the IP address as well as URI itself and a new line. and that gives us a lot more information. So that's even more IP addresses that are definitely doing bad stuff. So instead of using ... we now have this notation, which we definitely need to consider as well. And then there's a few entries that don't use the ... notation as a way to navigate up the directory structure, but that actually tries to include that file via a couple of other ways as well. So we need to grab all of those as well. So all of these IP addresses definitely count. I think most of the ones that we have from the initial query, they all fall out inside of this one as well. So this looks to be the better one of the two. Next up, SQL injection. Okay, let's see. There's a couple of things to keep in mind. The first thing is that there's different fields that we can actually query. So let me see if I can grab that. If I can grab one entry from the logs. Oh, obviously that's from my previous hint. I need to have the HTTP logs. I just need one. There we go. So one entry has multiple fields that it tracks, right? So we have host, for example. We have user agent, for example. We have username, password, all those kinds of things. Obviously, URI is going to be in there. That's something we searched for. Multiple fields or different fields can be used for these types of attacks. So in this case, as we're talking about SQLi, we're going to be searching through a few more. I'm not going to search through all of those fields because it's going to take us way too long to get through the end of solving this. But just to show you that there's different fields that are being exploited, I'll run the next couple of queries as well. So next up, we're going to look for URIs containing union, typically something that will be used in an SQL injection attack. Again, I'm going to print the IP address as we did before, URI itself, and then obviously the HTTP log is where we're going to grab this from. So that gives us quite a bit of information, or quite a bit of bad IP addresses with their associated URIs, which definitely show that there's some SQL injection happening here. Union select, trying to do that all over the place here. Now, next up, we can do the same thing and search in the user agent. And so if we do that, instead of saying URI here, we're going to say, well, the user agent needs to contain union, and just print the user agent together with the IP address. So let's run that again. And hey, look, same thing happening there. So that's definitely another field that's being exploited as well. And then finally, there's also, for example, the username field. So if we try and do the same thing and search for particular activity in the username field, and obviously this is something I know because I've searched a couple of days on challenge number 12. Thank you very much, whoever designed this, because at one point, to get to 100 IP addresses, I was considering everything to be bad. So yeah, anyway, 1 equals 1 SQLi injection, SQL injection rather. Let's see what that brings. We have a few of those as well. That's just because I know that it was in there. Anyway, that's a lot of IP addresses as well, so we have a few more that we added to our list at this point. Okay, so next up, moving up to shell shock. Shell shock has a specific structure on how it exploits, right? I'll basically run my search query, and you'll see on the output what the particular string is that's being used by shell shock to execute its behavior. So searching for a colon and then a semicolon in the user agent property or user agent field, and then printing the IP address and user agent is going to give us the following. That is, we can do the same thing for URI obviously, but that's not going to work. In the user agent it actually worked. So this is the typical shell shock string, and then after that you have whatever it wants to execute. In this case it's a bash shell script, and this is going to be opening up a connection back to a particular IP address. So all of these are definitely bad, so that's definitely IP addresses that we want to add to the list of things to track. Then cross-site scripting, obviously open and closing script tags. That's definitely something we want to search for. First of all, going to search in the host field. So there we go. There's a few of them in there. So script tags that pop up an alert. The way we search for that is just in the host field. We say it contains one of those opening script tags, and that's just it. We can do the same thing as well for the URI. There we go. and you'll get some more of them. So those are additional bad IP addresses as well. So all of that stuff that we have right now, so all of that, I think, if I count that, I'm not going to count it here obviously, but I think it's 62 IP addresses, so definitely not enough to cover those 100 that we need to submit to configure the firewall. But what I did to kind of, I'm not going to say solve this, but how I did this is I gathered all of these IP addresses together into a file named IPs_bad, and I added a bit more information in there. So let me show you what that looks like. Actually, let me just open it up. IPs_bad CSV, obviously. So I have the IP address that the activity originated from. I have the host name, I have the username, I have the URI, and I have the user agent there. So for each of the queries that I just ran previously, I just pushed them into a file with a bit more fields. And then I created this, I did the same thing for all of the IP addresses. So I had the user agents in there as well. Now, let's look at those user agents for those bad IP addresses. So the way I'm going to do that is going to cut that contents of the IPs bad, and then I'm going to cut based on the tab delimiter. I'm going to just take fields 1 and 5, which is going to be the IP addresses and the user agents, and I'm going to get rid of any of those user agent entries that were used for an exploit, which are going to contain union or the shell shock attack. Not interested in those. I want to really look at the legitimate strings for usernames in there. So let's do that. Let's see what's in there. If you go over this, you'll notice that in a few instances, things don't look the way they're supposed to. So obviously one is going to be this Metasploit one here at the bottom. I mean, that's something that we might want to search for and pivot off of. Gogglebot. Hey, it's Googlebot. Nice try, attacker, but that's definitely one that stands out as well. Apple WebKit instead of Apple WebKit, probably one that we want to track as well. And so all of these have, or some of these have at least. So we have Rookie here, we have this Cholt TB agent, one instance of wget, strangely enough, not more than that. There's a couple of compatible ones. There we go. There's one compatible with, not compatible with an E at the end. And so one more, Fun Web Products, Antivar XP, Tridents. So all of these seem to at least be funny in some kind of way, right? So what we're going to do next is we're going to go and use each of these user agents for each of those 62, at least 62 minus the ones that were used where the user agent field was used as an exploit. Those can't be used again. But all of the other ones, the ones that we see here, we're going to grab that user agent string. We're going to compare them or search for that user agent string in all of the IP addresses that we still have. And then if we find any other matches, we're going to add those to the list of bad IP addresses. Now, to make sure that we don't risk adding too many legitimate IP addresses, the moment that we find more than 2 additional IPs, we're going to ignore those results because there's too much of a likelihood that at that point we're finding additional legitimate IP addresses, but including legitimate IP addresses. We don't want to do that, obviously. So, looking at the script that I've written for this match user agents, let's quickly go over this and see what it does. So first of all, define where my bad IP addresses are stored in. So that's going to be this file name, and define where I have all my other IP addresses stored in. It's going to be this this file name. Define my array where I'm going to be putting my bad IP addresses, then the one where I'm going to be loading in all my IP addresses. And then I'm going to open up my file with all my IPs, read that one line by line. And as long as I have lines, I'm going to read one and split it by the tab character. I'm going to store that in that list all array, and then continue on with reading the next line. Now, as that is done, I'm going to do the same thing obviously with my bad IP file. So read that line by line as well. And for each line, same thing as before. I'm going to split that based on the tab delimiter. And then I'm going to start comparing each of the user agents. So I'm gonna take the fourth or fifth field, starts at 0 obviously, and compare that value between the ones from my all IP list to the ones from my bad IP list. And if it matches, I'm gonna add that to a temporary list that I'm keeping track of here. And then if after I go through that, I have less than 4 elements in that list, my original bad IP address and 2 additional ones, then I extend my final list of bad with those values. If that's not the case, I'm just going to skip over that. I'm going to add my bad IP, just the only one. It's going to be duplicate between those two if it goes through that if statement anyway, but I don't care because I'm going to remove duplicates afterwards anyway by converting it to a dict and then back to a list, which does just that. And so once that's done, I then print out that final list, first the length of that list, and then the IP addresses that I found, the original 62 bad ones, plus the additional ones that are matched based on the user agent. And that should give me the output that I need to add to the firewall. It's going to be CSV output with comma in between. So let's head on back to the script and let's see that run and see how that outputs. So Python match user agents. There we go. So now we have 97 IP addresses, and I was initially hell-bent on getting 100, but at some point I figured, well, let's just try and put those in and see what happens. And well, let's just put them in and see what happens. So weather map, paste all of those, say deny. And one of the frustrating things is that this progress bar, it's not an actual correct progress bar. But anyway. There we go, route calculation success, and we got the route ID as well. So, interesting challenge. Took me a while to figure out to pivot off of those user agents. And I think at one point it was mainly because I was kind of out of other ideas to do it other ways. So yeah, but anyway, succeeded, and let's see what happens once we paste in this in our badge. So there we go. Filter out poison associated weather data. That's a success as well. So let's exit out of this. Not sure if Krampus is going to say anything else. Nope, still the same thing. Wunorse, it's done as well. But we have the bell tower axis that's now opened. So we can go up to the bell tower. And that's where we'll meet up with Santa, Krampus, and the Tooth Fairy, who seems to be in jail attire. So we can talk to Krampus. Congratulations on a job well done. Well, thank you very much. By the way, he won the Wunorse contest. And that's no big surprise. And then Santa, you did it. Okay. Filled with glee. Awesome. Merry Christmas and happy holidays. That's perfect. Tooth Fairy, you foiled my dastardly plan. I'm ruined. And there come the credits. Now, one of the things, just move those credits real quick. Inspecting this element was kind of funny. Just want to mention it as well. Let's see if I can still find it though. Let's see. There's one thing in there that I noticed, but I can't find it anymore. Let's see if I can locate it real quick. Hang on. Give me a sec. There was one reference to a background image that actually described. Let me grab it real quick because it's interesting. Yeah, there we go. I'll just copy out the link. So one of the images here is going to be this image for this part. I initially thought this was snow. I don't know why I did, but there's no denying that based on the file name, that is quite literally a huge pile of teeth. So I figured I'd put that in there to make you aware of that as well. Anyway, so that is that. If you didn't notice as you went through the challenges, there's also a letter over here. So open up that letter in a new tab. And thankfully I didn't have to implement my plan by myself. Jack Frost promised to use his wintry magic to help me subvert Santa's horrible reign of holiday merriment now and forever. Sounds like Jack Frost has been quite silent in all of this, so could this be a hint on what's to come for next year's CringleCon? I don't know. I guess the only thing, or the only way that we'll know is if we come back to next year's event. Not sure where that's gonna be. If it's gonna be back at Elf University, if it's gonna be even bigger and better. I truly enjoyed myself in this year's event, in these past 12 challenges. I hope you did as well. I thank you if you watched all of these 12 episodes for sticking with it. I hope you enjoyed the time together, and I wish you all the best. Thank you very much for your attention, and see you in maybe some upcoming video. Who knows? Bye-bye.